Hello everyone. Today is day 2 of 75 hard research challenge. I am going to give a feedback or the review of what I did in the first day, that was 14th April 2024. So I studied two topics on natural language processing using AI, that is LLM decoding and something called prompt engineering. I also studied Atomic Habits, that's a book, very famous book that I have already read, but I am revisiting it again. So what is LLM decoding? So I studied these topics in this one called greedy decoding, beam search and sampling based methods. So let me give you a brief introduction of what is LLM decoding. So let's say you train a large language model on a pre-training task and then fine tune it using a supervised data set. Now at the inference time you want to deploy it based on the fact that someone will give you a prompt or a sequence of words, and now you want to extend that sequence by generating more words to it, right? So essentially you want to model the probability of ith word given first till I minus word that you have generated so far and the prompt that was provided by the user. So LLM decoding is all about how do we go about modeling this probability distribution and how do we go about sampling from this probability distribution. There are multiple ways. For example, greedy decoding, which essentially says that you take an argmax over this at each time step. That means you just consider the next word to be predicted and take the best possible word in the terms of the probabilities that was given to you over the vocabulary that was in your large language model, right? So there are problems with this. For example, what can happen is that suddenly you can end up generating a bad word, let's say accidentally or for whatever reasons the training was not good, and then rest of the sentence and that sentence generated so far will lead to gibberish or profanity based low scoring, right? So to handle this type of problem, what people do is that they do beam search. So rather than keeping or looking at one word at a time, what they say is that jointly model the probability distribution of the words generated so far, essentially meaning the probability of 1 to probability of I and prompt, right? What is the probability of generating this? Rather, prompt will not be included in this. Only the probability of the words that were generated so far, and for each next word possible you do it. That means for all I belong to vocabulary you do this, and you pick the top k out of these and each time step. So the next time step what you will do is you will expand all these k possible sentences so far and pick the top k among them. That essentially means that at each time step you'll have a previously generated k sentences, you expand them to k-squared sentences by plugging in one word at a time, and then out of these k-square you prune and keep the top k again. So there are particular benefits of doing this. It leads to diversity. It is more robust to generating bad words in a sequence, right? And all those things, right? So how do we? There's an important question that how do we terminate while generating these sequences? So usually what people do is that they use two criteria. First criteria is they see that whether the generator has, or the pre-trained model or the SFT model LLM of any form has generated an end of sequence form, an end of sequence token, or it has reached maximum number of tokens that are to be generated, right? So based on these two, you either terminate. For example, you might have seen that in case of certain APIs provided online, you can specify how many tokens do you want the model to generate, right? So let's compare beam search with the greedy decoding. So in beam search, if you use top k best possible sentences generated so far. So if you keep, where k is a hyperparameter, so if you keep k is equal to 1, you reduce to greedy decoding, right? And if you increase k too high, it has been noted that the performance usually does not increase, and it generates very generic type of sentences that are usually very acceptable. For example, it may end up generating that I do not know the answer, because that's probably a very generic response to whatever question you are asking, right? So there's one more thing that we would like to highlight here. We should highlight here that because we are multiplying probabilities here, that means probability of each word is w1 is getting multiplied by w2 is getting multiplied by wi till I, wi. So essentially what happens is, as you increase the length of the sentence, the probability goes down, right? So this essentially means that the model that is generating this sequence will prefer shorter sentences than the longer sentences. To handle this, people usually do some form of normalization of the based on the sentence length, right? The third method is called sampling based method. In this, you simply do one thing: rather than taking the argmax, you sample from the distribution that is given to you. That means that if you are given a distribution like this, that the first word has a probability like this and all of these add up to 1, then you sample from distribution. This leads to better diversity, but this can also lead to totally gibberish sentences being predicted, because there is a chance that every word can every token can get predicted, right? So it is probably not a good idea to use this on a not so well trained model. But in case of models like ChatGPT and other llama based model or Mistral based model, they have been trained and fine tuned on a very highly curated data. So the probability distributions are usually very skewed. They will already be very highly peaked at a particular point and all that. So this pure sampling may work there, as well as the greedy decoding also works there, right? To handle this pure sampling, however, there is a challenge with that. I will come to that. But to handle pure sampling, it is probably not a good idea to sample from a distribution that has a very long tail like this. For example, these words are probably very rare and probably do not go well with the rest of the sentence that was generated so far. So what you would do is you pick again top k tokens that has the highest probability. So essentially what you are doing is you are picking this particular word, that okay, this particular word and these, and then this probability distribution is then again of these particular words is then again renormalized and sampled from that. For example, if the probability of this is 0.1, highest probability is 0.1, second highest is 0.09, third highest is 0.07, then what you essentially do is that and k, top for k is given equal to 3, then what you essentially do is that you add them up and renormalize to get a distribution again, or right, and sample from that, right? So in case of top k, what happens is that this is better than the pure sampling, because you are ignoring the tail words which may be very rare and probably do not fit very well with the sentence. So what you essentially do is that in this case, in case of top k, let's see how do we reduce top k to pure sampling by varying the value of k. So if you keep the value of k is equal to 1, that means you are picking the top one word that is essentially equal to greedy decoding, right? But if you keep k is equal to vocabulary size, then you are making it pure sampling, right? So this is pure sampling and this is greedy decoding. Please don't mind my renting here. But there's a problem in this also, that as you are generating a particular sequence of sentence, right? You're generating a word at each time. The value of k is fixed for all of them, right? So can we do better than this? For example, maybe for a particular word, it is very clear that this is going to be the output. For example, in a sentence, for example, in a sentence that what is your name? At the end of this, probably the probability of having a question mark is very high, right? So can we dynamically vary the value of k was the motivation. So there was a paper in 2021 or 2022 which is called, or maybe 23, I do not recall, which is called top k sampling, which is a very simple idea. What they essentially do is that they say that pick k prime top values such that sum over I belong to this k prime range of k prime. Probability of I is equal to some probability value p. That essentially means that pick the top k values that add up to p probability, right? So as you can see, if a distribution is already very skewed, like peaked like this, then probably one or two values will be picked, right? One or two values will be picked. But if you have a distribution that is very flat, then the probability of picking any of these words is very high. So you end up covering more area, right? So this dynamically varies as you keep on generating a sequence of words, right? right? So in case of top P, can we do some reductions here? That means that can we reduce top P to, let's say, greedy decoding or pure sampling based methods? So answer is yes. For example, if you want to do a greedy decoding, that essentially means that you want to pick the top one word, right? So you simply say that set the hyperparameter value of P is equal to 0. That will always make sure that the top one word or one token will be picked. Similarly, if you keep P is equal to 1, that essentially means that all the vocabulary needs to be added up in each of these distributions to make sure that P is equal to 1. So that essentially reduces to pure sampling, right? So P is equal to 0 reduces to greedy decoding, and P is equal to 1 reduces to pure sampling based methods, right? Prompt engineering is something very trivial from the perspective of research, or something that everybody should ideally know it, because we do it all the time these days. For example, in the case of chat GPT, you type a query that is called a prompt, and it gives you an answer. But if you do not like the answer, then what do? You change the query a little bit, you give more instructions and all that. So that is what we call as prompt engineering, right? So there are multiple ways to do prompt engineering based on the type of message, or the mode of message, or attitude of the like person who is querying the system at that time. And these were developed over a period of time. So hence, they, in the hindsight, they may look very trivial, but they are essentially developed over a period of time. So they got a name assigned to them and so on. For example, in zero shot prompt engineering, what you do is that you do not fine tune the system. You simply ask it a question, and you give it a question. It will give you an answer based on that, based on whatever it has been trained on so far, whether it was pre-trained, whether it was fine tuned, whether it was some other way people have done it, right? So in the case of few shot, what you do is that you ask it a question, but before asking it a question, you also provide it some demonstrations, right? In the case of zero shot, you simply ask your query. In the case of few shot, you give a demonstration and then followed by a query. For example, you can say that in the first case, you can simply say that what is 10 into 2, right? It can reply 20 or 18 or whatever it has been trained on, how good it is, right? But in the case of few shot, sometimes you need a few shot answer. For example, you can ask a question, let's say that if star represents addition, right, then like what is 10 into 2? Wait, let me just go ahead and make it demonstration based. So essentially you say that if star represent additions and 10 into 2 is equal to 20, 10 into 3 is equal to 30, what is 10 into 5? All right. So essentially what you are doing is that you are giving certain demonstration of the task that you need to do. That means you are telling it with some examples, and now you are asking it what is the final query that whatever you want to ask. In case of instruction tuning, what essentially people do is that you give as detailed query as possible. For example, you usually give it very high level of instructions, or very detailed instructions, sorry, that saying that generate me a paragraph of text that contains 5,000 words exactly, and there it should be divided into 3 parts, where the first part should be an introduction, second part should be a technical analysis, and third part should be a conclusion. The conclusion should not have more than 3 sentences, and so on and so forth, right? So this type of very well defined queries, very well defined tasks are usually categorized under instruction tuning. There's another way of handling this that people have recently seen, is called something called self improvement. In the case of self improvement, what you do is that you ask it a query, right, that tell me the answer of this, or generate me a question with some constraint. You say that generate me a paragraph, a creative paragraph over life of a unicorn in Bangalore, right? And then you say that it should not be more than 3 paragraphs, and it should the name of the unicorn should be let's say Anna, right? So you gave it a query along with some constraints, right? Let's say. Now what happens is that sometimes what we will see that it generates a response, and this response does not follow the constraint it was given. So you ask it again, you ask it to critique its own answer again and ask it, is your question, is the response generated to my query follow all the constraints or not? Then it will give its response as yes or no. For example, let's say it does not use the name of the unicorn as Anna, or it does not mention the city Bangalore. Then what it can do is it will say yes or no, right? So based on that, you ask it to reword or rewrite its response, right, to regenerate its response. So what people have seen, that usually the first response that was generated and the final response that was generated is miles apart, and it is much better than what one would expect, right? So this type of self improvement people have seen that it's very good, and people have taken it to a whole new level, that they ask two LLMs to interact with each other, or ask one LLM to critique the output of the other LLM before giving it as the output to the final end user, right? Similarly, people have developed something called chain of thought, which is a very simple idea, but it worked like a charm at that time when the paper was published, and they did a beautiful analysis on top of it. Essentially, it says that just by adding the words like think step by step, the level of response and the level of output, the performance of the LLM increases very well, right? So it might seem to you that this is not a research based topic or whatever, but given the era we are living in, this is what people are interested in, and this is what is the initial phases of large language models. Eventually we will move past it, or the bigger companies will already include all these in their training and decoding like phases. For example, it is well known that chain of thought decoding is already a very highly used prompt internally by ChatGPT, even if you do not mention it and all. So yeah, to conclude, we studied like LLM decoding and prompt engineering yesterday, and I gave you a small brief introduction on top of it. I'll not go into what I studied in Atomic Habit. Maybe I'll make a larger video once I'm finished with the book. Thanks.